Hi everyone. I hope everyone's doing good and had a nice vacation, a little break from whatever our new normal is. I wanted to do a quick PowerPoint. I'll put this PowerPoint up on Classroom to kind of refresh cell membranes and osmosis and diffusion. Sorry if it's shaky, but I'll try to go through it quickly. There's going to be a Google form of questions to answer after this. Okay, so movement through a cell membrane. Remember that cell membranes are selectively permeable, which means that they are selective about what they allow in and out of the membrane. So if you're selective, you choose what can come in and come out. So here's a membrane, and only certain things come in and out. So in this example, the only thing that's allowed in and out is the water. The water can move freely from an area of high concentration to a low. So molecules, like anything else, don't like to be crowded. If you picture our entire class getting in the elevator at school, and we're all crowded in there and everything's annoying everybody, as soon as those doors open, you're going to want to get far away from people as possible. So that's what molecules are. If they're all concentrated or crowded, they want to get away and move to where they can have enough space. So that's what these water molecules are doing. But these sugar molecules can't. So they're still kind of crowded and annoyed with each other. And they can't move because they're too big. So membranes decide what come in and out of them. Their selectivity is based on the size of the molecules. So that one we just showed, the sugar was too big. The shape, if it's oddly shaped, it's not going to let it in. And then of course the concentration, which we've already talked about. It moves from high to low. So if you look at this, another example of a plasma membrane, it's a double membrane, remember, lipid bilayer. And over here again are water molecules, and these are our sugar molecules. So there's a higher concentration of water molecules here, so eventually they're going to move across until there's equal concentration on either side. But these sugar molecules are too fat. They can't. Passive transport is when things move in and out based on concentration. Just passive, like the water molecules, or this example, oxygen molecules. They are the right size, they are the right shape, and they can just passively move in and out. Think of someone who's really passive. They're just very calm and cool and collected, and they don't take a lot of energy to kind of be around. So one example of passive transport is diffusion, which we've talked about, when they move from an area of high concentration to an area of low concentration. So in this example, this cell, there's 2 molecules of oxygen on the inside, and there's 6 on the outside. So they're going to move in until they're equal. A specific example of diffusion is osmosis. Osmosis is just the movement of water. So it's a movement of water molecules from an area of high concentration to low concentration. And when you talk about water, you talk about this thing called a solute and a solvent and a solution. So the solute is like a sugar or salt, like sugar water, salt water, anything that dissolves in water. And the solvent is the water, the red ones. The universal solvent is water. A solution is made up of anything dissolved in water. So here in the semi-permeable membrane, the water, of course, is moving, but the big fat molecules can't. There are 3 types of solutions when it comes to osmosis. Hypotonic solution is when there's higher concentrations of water on the outside compared to the inside. So this is a little confusing because it gives 10% salt, 20% salt. But if this is 10% salt, that means that it's 90% water because they have to equal 100. Inside is 20% salt, so it's therefore 80% water. So there's more water on the outside than the inside, so the water is going to move in. And then when the water moves in, the cell gets really, really fat, like a hippo. Hippos are fat. So hypo. Sometimes the cell can explode when this happens. Opposite of that is called hypertonic solution. That's where there's more water in than out. So again, if it's 10% salt, that means that it's 90% water. If it's 20% salt, it's 80% water. So there's more water in than out, so the water rushes out and the cell shrinks. This is what your fingers do when you spend too much time swimming or in the bathtub. They shrink. What your cells are in right now in your body, in the perfect scenario, and what you want them to be in is called an isotonic solution, where there's equal amounts in and out. So water molecules move in and they move out and they're just happy. The cell is a good size. It's not exploding. It's not shrinking. These are what your cells are in right now. They're happy. So an interesting thing that I always tell is, if I go back to the hypotonic solution, if you have, let's say, a fish that lives in salt water, and if you take that fish, so it's probably, 20% salt. If you take that fish and put it into a freshwater ecosystem, all the water is going to rush in to try to equal out that water in the fish. What's the fish going to do? It's going to explode. Don't try this at home. That was a hypotonic solution. Hypertonic solution is if you went the other way. If you took a freshwater fish, like a trout, and you put it, so it had, 10% salt in its body, and you put it in ocean water, if you put it in there, all the water is going to rush out and the fish is going to shrivel up. Don't try this at home. But lastly is the isotonic solution. That's where saltwater fish are with saltwater and freshwater fish are in freshwater. I hope that this helps. Please take this information and fill out the Google form, and then we'll move on from there. All right. Bye, guys.